Welcome to my second class. Last lecture we saw how to, what is rational number and what do you mean actually by rational number, and we also located rational number on number line. Then we compared the rational number. So in that we saw that we have if we have two rational numbers, say in the form of a upon b, c upon d, and we saw that when you multiply a times d and you multiply b times c, so if a times d is greater, then your rational number a upon b is greater than c upon d. Okay, if your a times d is equals to b times c, then both the rational number are practically equal. And if your a times d is smaller than b times c, then your rational number a by b is less than c by d. So this is a short update on our last video. Now in our this session we will now try to represent a rational number into a decimal form. So decimal representation of rational number. So in that, like if we use decimal fractions while dividing the numerator of a rational number by its denominator, then we get a decimal representation of a rational number. So likewise, if you have 7 upon 4, then you divide like the actual division and you get some value, like, right, 1 point now 28, and then remains 2, and then 5. So your value of rational number 7 upon 4 is 1.75. So this is the decimal representation of a rational number. But such a decimal form of a rational number is called terminating, right? It's terminating. So terminating decimal form, because it terminates, you get a value of 0 over here. So such kind of rational number are known as terminating decimal rational number, or it can be represented into terminating decimal form. But then there is something which is known as non-terminating recurring decimal form. So in this, what will happen, we'll try to see an example. We have a 7 upon 6, and if you divide 6 with 7, so you get 6 ones are 6, and then your remainder is 1. You add dot, you add 0. So now again 6 ones are 6, and you get 4, 40. Then you 6 are 36, again 4, 40, and then this 6 will keep on going, right? It will not end, it will not terminate. So therefore such decimal forms are known as non-terminating recurring, because 6 is recurring decimal form. So 1.1666 dot 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 dot. So how do you write this? You cannot keep on writing 66666. So you can instead write 1.16 के ऊपर a small dot which says that this 6 is recurring. So 1.16 recurring. Similarly, we have, like, say the number 22 by 7, which is the value of pi. So when you divide 22 by 7, so you will get something like 3.142857142857142857, and this will repeat 142857. So instead of writing this repeating one, you can write 3.142857, and where 142857 is recurring. So to represent more than one number as recurring, you just put a dash above it. Okay, so pretty simple. Now let's try to solve some problems. So suppose you have 9 by 37. Now of course it's a kind of big number, 9 by 37. So you divide it, 37 and 9. So of course you are not going to get anything. First you put 0, and then 37 times 2 is your like 74, and then you have some thing remaining, 16, again 160. So you will have some value again, 37 times maybe 6, no, 37 times maybe 5, or not even 5, you have to go 4. 37 times 4, 148. So 148 subtract times 4 times 4, and then of course your 120, then again times 3, right? So 37 times 3, 111, and again you are remaining with 9. So now you will get again the recurring number 243. So your value will be 243 and dot dot. So you can write 0.243 wherever 243 is recurring. So very simple, you have to divide, and when you see a single number or single digit recurring, then you can simply write that digit and then a dot representing that it's a non terminating recurring decimal form. And when you have more than one number like 0.234, 234 or 243, then you can write it as simply 0.243 bar, which is again a non-terminating recurring decimal form of 9 by 37, whereby 243 is recurring again and again. So that's kind of clear about how to convert a decimal, how to represent a rational number into a decimal form.